So in this, we are going to review last week's homework that I asked you to do, those 4 questions for your quiz that you're going to take today. So you want to get that out in front of you. It was these 4 questions on the packet that I had given you a week ago. All right, what can we determine from the diagram and the givens? For the following diagram, list everything you know is congruent and why. Be sure to list all sets of sides, angles, and triangles. Make sure your reason why is in the form of a postulate, theorem, or property or definition. So let's mark our given on the picture first off. It says the segment AE, and that's how you're going to read that here. The segment AE bisects the segment BD. So AE, this segment here that goes from A to E, is bisecting the segment BD. That means it's cutting it into 2 equal pieces. So you could put a tick mark there and there. Okay, so we could make the statement over here, and this is what we need to write. You're going to write BC, that segment is congruent to segment CD. Now, how do I know that? Because that's the definition of a bisector. Okay, that's what a bisector does. It cuts it into equal pieces. That's how we know that. Okay, now we also know that angle A is congruent to angle E. So I'm going to put an arc mark on A and E on here. So we have those. So now it's just given. We don't really need to justify that or anything. Again, that was given to us. So we have these 2 pieces of information. Now, alone, this isn't enough. You cannot prove, so we can't determine anything here, except for we do have something else we can add. You have vertical angles at those 2 angles right there. So you can say angle ACB, and notice how I'm using 3 letters to name that instead of just saying angle C, is congruent to angle DCE, and that's by the vertical angles theorem, by the VAT. So now with this information, I have 3 pieces of information. Now you have to be mindful and make sure the pattern's the same. So my pattern here, I see I have an angle, and a side. I have an angle, and a side. So my pattern is angle, angle, side. Okay, and that's one of our 4 theorems. If you remember our 4 theorems, it was side, 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 congruence, right? It was side, side, congruence. It was angle, side, angle, congruence, talking about the included sides. And then it was angle, side, congruence. So those were, ignore that little whatever. So that was one of ours. So on this, it definitely fits our pattern. So these triangles are congruent. Again, you also have to be careful here. We went single to double arc mark. So single arc mark to double arc mark to a single tick mark. We went single arc mark, double arc mark to single tick mark. We're not going to typically try to trick you on questions like this, but we could have maybe upped the difficulty by kind of messing with how they were labeled on the picture. Remember, they both have to be the pattern angle, angle, side. If they weren't, you can't fudge it and make it work how you want. So we can make our congruent statement. So what can we conclude? Well, we conclude that triangle, and remember, you can start it any way you want. And since we like the alphabet, triangle ABC is congruent to, now, again, however you start, you have to match it when you finish. So if I went ABC on here, ABC, I went single arc to no arc to double. Again, that's a way that I like to look at it. So we're going to go to single to no to double. So it's EDC. And our reasoning, and I ran out of space here, is angle, angle, side congruence. This is what you should be doing for these. So I briefly mentioned on here what this means, talking about C as a midpoint of BD. But let's start from the beginning on the given. So segment AB is congruent to segment ED. So segment AB is congruent to segment ED, so I can use a single tick mark there. We know C is the midpoint of BD, of the line, segment BD. So I know that then BC is congruent to CD. So again, BC is congruent to the segment BC to CD. And why do we know that? Because that's what a midpoint does. So that's definition of a midpoint. Okay, definition of a midpoint. All right, so we know that. Now let's go down here. This upside down capital T here and here means these are perpendicular. So if segment AB and segment BD are perpendicular, BD is right here, that means that's a right angle there. And if segment ED and segment BD are perpendicular, that's a right angle there. So these are both right triangles. And we know that all right angles are congruent. So because of that, we have the pattern side, angle, side on both of these, side, angle, side. So we can say that triangle, again, let's go, way to be unoriginal, right? Triangle ABC again, okay, is congruent to, now again, I went from A to B to C on here, so I went single tick mark on a side to a double tick mark. So I need to have that same exact pattern. Single tick mark to a double tick mark here. So it's going to go EDC. Okay, and then again, I kind of ran out of space, so I'm going to write it kind of down below here, but it's side, angle, side congruence. The ray QS bisects angle TQR. So TQR is this angle all the way over here. So if the ray QS bisects it, that means those two angles there are congruent. So you can say angle RQS is congruent to angle TQS. Okay. So again, we can say those are equal to, or sorry, those are congruent to each other. And the reason we know they're congruent to each other because that's the definition of bisect. I know I wrote definition of bisector on the first slide here, or whatever slide, first question, I guess. As long as you get the general idea, definition of bisector. And I know I'm leaving off some words here, but we're just making it fit, and yeah. Okay, so we also know that the ray SQ bisects TSR. So, or sorry, yeah, TSR. So we can put a double arc mark here and here. So it's the same thing. It's just from the other side. So, you know, angle RST. Again, it's very important. Whoops, not RST. See, now I'm making mistakes. RSQ. So we can say that RSQ is congruent to QST, angle QST. Please note the notation I'm using for this. Okay, so we can say those two angles are congruent to each other, and it's the same reason, and I don't know if you remember this from forever ago, but we can use that little short, meaning basically repeating the same reason. Okay, so now we're looking at this. That's only two pieces of information. You need a third. Well, we definitely have the segment QS congruent to itself, and that's by the reflexive property. Okay, and I'll let you even go that short on that one. So these triangles are congruent to each other by the pattern angle, side angle in each of them. So again, triangle, and we don't have, we can go QRS is congruent to triangle. So I went QRS, that's single arc mark, no arc mark, double. So single, no, double, so it's QTS. And then I can actually fit it on here. It's angle, side, angle, congruence. All right, the last of the homework questions I gave you to do. I know that Vx is congruent to xy, and hey, that's already marked for us. That's nice. Thank you very much. I know that the segment xw is congruent to the segment yz, so there's a double there. Okay, thank you very much. We have that already, so we don't need to do that. And then I also know that these two lines here, sorry, these two segments are parallel, which we already have that. Now, when you look at this, you're going to say, okay, you might be tempted to use vertical angles theorem. Don't do that. Okay, vertical angles theorem does not help you. Linear pair postulate does not help you here. There actually is no vertical angles theorem on this picture. So now when you're looking at this, it's the parallel lines that you need. Now, there could be a situation where we don't have enough information. Now, I'm going to tell you that we do. Okay, but I mean, there could be a situation where I give you something that's like there's not enough information and you can't do anything else. But on here, what I want to do is I want to just take and I'm going to erase this, but let's just draw these two and let's turn them into lines. Okay, so here's, you know, here's X and here's W, so put points on there. And then here's Y and here's Z. So I'm going to mark them like this. And then I'm going to go ahead and draw a line right through the X and Y. And I'm going to say, hey, these are parallel to each other. And so if I do that on here, I guess I should have done a little better than that, but I think you get the idea here. Well, we know all the things that are true about parallel lines cut by a transversal. You know, alternate interior congruent, alternate exterior, same side interior supplementary, or the one that we're going to need is that the corresponding angles here and here are congruent. So you can actually say this angle here and this angle here, they are congruent. All right. Even though you have this segment coming through here, what happens is a lot of students get confused. When we stick that XZ, it has nothing to do with those two angles I just marked. Okay, so let me erase everything that I put on here now over here because we're going to need the space. So now what we know and what we can add to here, everything else in the given is fine. We actually don't need to write any of that down again. But what we are going to say here is we're going to say that angle VXW is congruent to angle XYZ. And really on this, you could have gone VYZ. So you could have used the X or the V for naming that angle right there. Okay. But anyway, they're congruent to each other. And your reasoning is that lines cut by a transversal are parallel if and only if corresponding angles are congruent. So we're using something from last chapter. And now we have side angle side. So we could say that triangle VXW is congruent. Again, you can start it any way you want. It's about finishing that matters, okay? So that triangle, and so we're gonna name it the single tick mark to the double tick mark. So I'm gonna go single to double as well. So I'll go XYZ. Okay, and your reasoning for this is side angle side congruence.